Okay, welcome to this live stream. We are looking at visualization features for version 12.1 of Wolfram language. And, oh, that looks exciting. Okay, so what are we looking at here first?
As a preamble, vector plot is one of the few visualization functions where you're unlikely to be successful the first time you use it. Okay, so we've greatly improved the automation and the structure of how you specify things. It was a super complicated way. And when you iterated, unless you really committed, you were unlikely to be successful in tweaking the options. And now we're also using vector plot in a variety of other ways. So there's a complex vector plot and there's a geo vector plot. And so the problem became more urgent. So this is basically a dramatic overhaul of the vector plotting functions, the one that uses glyphs, not stream plot. Stream plot is just fine, but vector plot.
Right, so the issue is with a stream plot, there's no ambiguity in where the streamlines are. If you can compute them, you can draw them. Whereas in a vector plot, there's the question of you're representing this vector field using samples of the vector field and showing arrows at certain points.
Right.
It's not clear where those.
So let me describe some of the aesthetic challenges that were there, if you that we've addressed. One problem was that we were mapping the norm of vectors. So you're plotting a vector field and the norm, the length of the vector, to the length of the arrow.
Yep.
Okay, that didn't give us a lot of bandwidth to express different sizes. So you would have vector field vanishing and to show no.
Yeah, I understand. Or it crashes into each other.
Right, but we bound that anyway. But yes, you would get that unless we'd done that. But the effect of that is that the biggest one is going to fit, so it drives the older ones to zero. So that's we can get.
I've seen that many times. Yes.
Yeah, it's horrible, right? So the first mitigation is to get better dynamic range by using nonlinear transformations to do log scale and other things. But that still doesn't solve the problem. It mitigates it, but it doesn't solve it. Now the other thing that we've gone with now, so that's there, that improvement is there, and it's much easier to specify how you sort of scale those magnitudes. But the default setting, we don't scale them, and that's usually called a direction field. We map the magnitude onto color because we actually can assume color, and we've been using color more. And so that's the default setting, and it's an easy flip if you want to go with magnitudes instead.
So we're changing the default, is what you're saying.
We're changing the default. And there are some new option names. So they're much easier option settings. They're not 5.
Do we have somebody from design here? Do we have somebody from design?
We have Tim from design.
Let's ask, can Tim join us? Is Tim here?
He's not, but we can grab him.
Could you? And then I wouldn't mind asking Jeremy to join us if he can for a minute. I mean, just to go over these final aesthetics here. I mean, this looks pretty nice.
It's now, I'm super proud of this function now. It's now a function that's successful at first try, and it's solid. You know, there's some final little tweaks before.
Roger, I'm just going to complain about some things to do with these colors, okay?
So those rainbowy colors
are wrong.
Oh, well, okay, fine. then that's a simple, okay, can you send me what's right?
If you scroll down a little bit farther, there's examples that are right. And I'm not happy with the new ones either. So, let's see, Justin, can you send Tim Shuttlebauer the the Zoom info as well, please?
Yeah, and we want Jeremy Davis too.
Yes.
Okay.
Okay. So if you go down to the section probably after vector points.
Yeah. Let me just.
Right. So vector range, clipping style. Those should all be right. And so this one is. I think I went back, too far the other way, and so I was using a slightly darker version of what.
Let's wait for our design folk to be here so that we.
Yeah. The bottom line is that you want a sense of scale for that. Because if we map norm or magnitude onto that color, so you want that intuitive feel of scale. It's from small to large.
Right. Okay. Do we have our design folk here or not?
They should be
I-
coming.
Yeah, I just sent them a message.
Okay. All right. Okay, but let's keep going on just me understanding. Okay, so first thing is flipping magnitude becomes color.
Mhm.
Then, so this vector points thing, that was an existing option, is that correct?
That was an existing option, and it was something like vector points goes to 10 or 20 or 20
So
comma.
it's the analog of plot points, and that's
Yes.
giving us the I don't know what you call it, the density of sample points.
It gives you the grid.
Yeah. By the way, can I just make a random graphics complaint? Why is Contour Plot so unbelievably memory intensive? And is that fixable?
I'm not sure off the top of my head. I think it
Could you
goes
take a
through
look?
2 rounds of subdivision, though, which might contribute to it.
Could you take a look? Because it's killing things in the cloud very regularly.
Contour plot is?
Yeah, Contour Plot. Okay, so vector points now has some named options that represent different strategies for where to route the vectors, so to speak.
Right. And we're proposing switching to hexagonal by default
Okay,
instead of a square grid.
sounds highly sensible to me. Hexagons have more room to maneuver, so to speak.
Well, and it allows our vectors to be a little bit longer by default.
Yeah, right. Okay. Vector markers. Okay, so that's what to do, whether to have an arrow or something else.
Right, and that's old. That hasn't changed.
Okay.
That's just showing off a couple of the algorithms for selecting points.
But so this business about arrow length, I mean, we do have to have a version in which arrow length does represent.
We do.
Yes.
Intensity.
Yes.
Okay. We do.
It's
So
the next section. Right. So there's that vector field, evaluated in V12. And it has a couple of poles, and so everything just vanishes.
Right. Okay. Vector scaling, is that a new thing?
So vector scale is an old option that is practically incomprehensible. So split it into new options, and replaced its meaning essentially.
So vector scale is still there, or vector scale is gone?
Vector scale is still there, but it will, the documented behaviors will be something different.
By
with
the way,
backward compatibility.
and if you look at the source, you can see the new.
sorry, what?
If you go to source notebook, you can see what the new proposed is.
There's a vector scale new notebook. So.
Okay. So it goes from min to max. And this is how it does it. Is that right?
Mm-hmm.
What is the actual setting? It doesn't say what the settings are.
I mean, those are, what do you mean? What are the settings?
Well, where's the setting with smin and smax?
Vector, that's in a new option, vector sizes.
It says given by vector sizes.
Oh, I see.
In
Okay.
that same paragraph you pointed. You're
So what's the analog of vector scale in an ordinary plot? Is there some other scale thingy?
I mean,
not really.
So
No.
if you look at the one in your help browser, window behind that one.
Yeah.
Yeah, so there's automatic, large, medium, small,
No.
tiny.
I'm not asking that question.
No.
I'm asking in an ordinary plot. What
Yes,
is
yes,
the
yes.
analog?
My answer is there isn't one.
Okay.
And because if you look at it,
I just think
it goes
this
from the
name is
simple
awful.
settings.
Right. I think the name is awful. Okay. I think that this should be something like, vector scaling function or something, or vector scaling. What?
Yes. Well, that was exactly what I proposed.
So we went from vector scale to vector scaling. Sorry, to vector scaling function, back to vector scale, to vector scaling, back to vector scale.
Okay. And why did you do that?
Because we wanted to not have this one sit out there. The only reason this was an old symbol we had.
Obsoleted.
Yes.
It's a terrible name anyway. We should just obsolete it.
Okay. In which case, I think Roger and I prefer vector scaling.
I agree with that. I think vector scaling, but given that there are a bunch of string named cases, is the right thing. Okay. All right. So should it be vector sizes or vector sizing?
It follows bubble sizes.
Let's look at bubble sizes. By the way, whatever is happening with that autocomplete is very, very, very weird. You see that thing bubbling?
I'm glad I'm not the only person who thinks so.
Okay, could we report that? Could somebody report that, please? No, do I?
I will report it.
Okay. Well, it's a little weird because bubble sizes is a lot more. Vector sizes I could live with. I mean, honestly, this could have been bubble sizing.
Yes.
I don't know. I would prefer vector sizing because I think vector size is just so generic. And we could even consider, having bubble sizing as an alternative and eventually deprecating bubble sizes.
It's not that important. Come on.
Well, which one? What are you proposing?
No. I mean, to change bubble sizes because you have a sort of a different part of speech preference 10 years later.
Yes.
I mean, so why sizing?
Why?
All right. Okay. Vector size is fine. I just worry that vector size is going to end up we're going to end up wanting to use that for some other thing that is more centrally, whatever. Probably not. Okay, fine. Okay, let's take a look here. So vector aspect ratio, what does that mean?
So that is, especially in the case where you're drawing these glyphs, it controls.
I get it.
The space that the glyph is drawn into.
Which is always a rectangular thing that's not necessarily aligned with coordinate axes. Is that correct? Okay. Okay, let's talk about guide pages now have icons. Oh, cool. Let me see one of those.
Let me see another notebook because I forgot to send that.
Okay. But let's come back to the question of color for these guys here. Okay. Can you send me what you think is the current color setup for these? And then how do I determine the color? Is it a color function?
It is through an option called vector color function, and
I don't see that option here.
It hasn't changed.
It hasn't changed. It was existing.
Okay. To determine colors of field vectors. Okay. Okay. But so previously that was set to none or something. Is that right?
Right.
I think it's always been automatic. It's just automatic was nothing.
Well,
Wait a minute. Vector plot is, these are the things being fed: x, y, vx, vy, norm, vx, vy.
Mm-hmm.
No, it's a vector color function arrow name indexes into the color data.
That's how they all have been working.
Yeah.
I understand. Okay, so what did it do before? What about all the other functions that are mentioned here, like stream plots and things? I mean, stream plots, there's no reason to color it, right?
Right, but it's automatic, so it will still not color it.
Okay. Okay, so I mean, you've broken out into, like, not being in Kansas anymore, into color with all the complex plot 3D and so on stuff, which is the first cases where I think our default plotting is color, uses color in a non-trivial way. Isn't that a true
Yeah,
statement?
I mean,
Well, I mean, other than
does.
density plot.
Density plot does, but it's
Well, but density plot could be a pure grayscale, although isn't it by default grayscale density plot?
No, it's
no, it's the same color scheme as the rest of the plots.
Okay. I mean, I personally think we might want to liven up our color scheme in general sometime soon. But okay, can we please see what the default colors that you're proposing here are?
not easily.
Well, can't you just show me your screen?
I can't generate those three in the default colors.
Okay, why not?
Well, I can probably do 2 of them, but
I
that's
don't need to see all 3. Just let's see the hexagonal case in can you just send me either a screenshot or
Yeah. I need to get my build and figure out.
And maybe Tim can say what the default color function actually is.
Which field is that? Okay.
Is Tim with us?
Yeah, I'm here. I'm not sure. I didn't work on this, so I'm not sure what these are.
Who did?
Yeah, Tim's going to redo.
Wait. Who did work on this?
I mean, we are just now deriving sort of the actual final color functions.
Okay, fine. So there
this.
aren't color functions yet. Okay.
Right. No,
Okay, so
we had
I'm
one in
objecting to
place.
these ones, but
No, we did too, right? So, but
Okay.
there were a zillion other problems to solve along the way.
all right. Okay, fine. Is there anything else then? Given that we're looking, I think this looks beautiful, but let's maybe loop back to the color function and go through some of the other things we have to cover during this meeting.
Sure.
Sound fair?
So yeah, so next up there, so this is a big, we're very happy about this because now this part of the system we can be proud of too, and it will always work.
Which?
Vector plots.
Yeah, I agree. I think it's very nice. I mean, listen, I made vector plots. I mean, I'll show you an example of a bad example. You want to see a bad example from a long time ago?
Oh, we have
See what it
plenty
did?
of those.
Well, I'm going to show you one.
Let's see your favorite bad example.
No, I mean, but this is a bad example. Probably made with packages. I have no idea when. Let's see. Okay, so here's an example of, I don't know how well we can even see this, but this is an example where this is a vector field, right? And I think, I mean, this one, you kind of can see what's going on, but it's very annoying. I mean, this had to be tweaked a lot to actually be able to see what's going on.
Right.
And presumably in your proposal, the vectors might get pretty random out here. I mean, that's another issue. The short vectors may be pretty random looking.
Right, but they're all equal length. So if they're random orientation,
It'll devolve into noisy colors.
yeah, but you will see that
No,
it's
there won't
random.
be colors. There won't be colors. It'll all be the same color. They're all short. Right? You see what I'm saying?
If you want to go with sort of different lengths, then they'll have that characteristic. Yes.
No. I'm saying that in your model, right, in your thing here, the lengths will all be the same. The lengths are just determined by the unit vectors. Right?
Yes.
Mm-hmm.
Okay. So in this picture, what you will see is brighter colors here.
Yeah.
Because there's more velocity field.
Right.
Over here, what you will see is a bunch of random direction things. And this, by the way, should inform the color function, because actually when it should gray down in the case where the things are short, because otherwise what you're going to see is a jumble of crud there. You see what I'm saying?
Mm.
right? It's an argument to have the colors get lighter or grayer as it goes to 0. In general, by the time it's very close to 0, the unit vector is going to be in a totally random direction.
Well, you're right. So we need to do experiments with that before we know.
Fine. Okay, so I'm predicting. I think this is a good case to look at because it's going to come up in a lot of CFD things where there's a background field that's close to 0, right, and where there's action somewhere.
Right.
Mm-hmm.
And you got to make sure that looks good. I think it can look good by having, even though these things are all random directions, it'll be sort of gray out there.
Right.
Okay. And I think your case here, I think the case where you've got, you'll find the same thing in a dipole field, which is what you got here, basically, right?
Mm-hmm.
The problem with the dipole field, the reason you're kidding yourself here is because you didn't do, this wasn't, this is an exact function. It's rather easy to compute, right? Whereas if at close to 0 field, the thing is, it's I think you should get one which is computed with numerical, with some numerical method so that the thing gets a bunch of errors close to 0 field.
Right.
Yeah.
In fact, what I would do is take the vector components and give them random noise, because that's going to randomize the, close to 0 field, it's going to randomize the direction.
Mm-hmm.
Okay. Okay. So, do we want to look at anything else here? I was going to look at the guide page. Did you send me that?
I sent you the notebook with the guide pages.
Well, for some reason that's not working. Will it work in? Oh yeah, there we go. Oh my gosh.
And so each of those sections is a link to
Magnificent.
guide page new.
I think these need to have. I think
a little bit more space.
Yeah, more space, tight, slightly smaller icons. Yeah, definitely more space here. That's not going to work. I mean, then you have got to treat this slightly differently. I think this is a show it to Jeremy type situation. Okay.
Mm-hmm.
I think these need to go down by like 20% in size relative to that font size. I don't know how the size is coded, and you need to check. And let me try it here. Okay, that works nicely, and they're all vector graphics, right?
They're all PNGs.
Okay, you should talk to, in the world of high DPI support, you need to talk to Jeremy to make sure that that's going to work, right?
They are high DPI PNGs.
Okay, fine. All right, you're ahead of that.
Right, and then there's a few cases where we haven't generated the icons yet for some new functions.
Okay. Okay, cool. Sandra is asking about the fluid dynamics. No, the plate is moving. The field is at infinity. The fluid is stationary. This is a co-moving frame with the plate. Okay, great. Let's keep going here. Geo Density Plot. Do I need to look at that? Actually, I haven't seen Geo Contour. Have I seen Geo Density Plot? Is that in
No.
12.0?
No,
it's not in 12.0.
Have I seen it before at all?
I don't think so.
I don't think I have either. I think that's interesting. So like that's the gridded population for the Earth or something.
Something like that. And the examples, especially for density, we need some better test data that, for examples.
I think there's a gridded population for the Earth in the data repository.
Interesting.
This looks really weird. I don't understand this. So this is kind of like, this is a haze on top of the base map.
Yeah. So they all have kind of an opacity because you need to know, you want to know where you are often.
Well, yeah, I know, but this one we're not seeing any opacity at all. We're not seeing anything there.
Yeah.
I think there is. You just aren't. It just doesn't show up well. And that data is just elevation, which.
Yeah, I get it. But I mean, so if I said, so let me just understand this. So presumably I can actually run this here. So if I say geo elevation data of, Mount Everest, let's say geo range, 5 miles. Okay, that should give me a geo elevation thing. Now, oh boy, that's a disembodied quantity there, isn't it? Okay, that's an issue for Jose and people.
Right. I mean, and if you look at the geo elevation data call in the Geo Density Plot docs, you'll see that it is possible to get the non-disembodied data out of it.
I can see that, right. But it's a mess. So this is something we need, Jose. Can somebody see if we can find Jose, given that we're now talking about geoplots?
Yeah, I'll go track him down.
Okay. That doesn't make a lot of sense to me, that's not possible to bring that in there. Because this is basically painting data on a something not good about that. Now, Geo Contour Plot, obviously that would be the most natural thing in the world to have as a geo elevation thing, right?
Right.
And is it still a total mess to get it out for that?
It's the same. It's
okay. But so if I say now Geo Contour Plot of that %1, it's just going to go bonkers, right? Yeah. So if I say contour, that will be a list contour plot.
correct.
Of %1. Okay, I'm telling you, contour plot is just the most, horrible function. I really think you should look at contour plot. I think it's bad. And that color map is pretty awful, I think. I think the colors are uninspired and not very clear. That was a comment relevant to Tim, I think. I mean, I suspect these colors predate Tim.
No, these are the V10 colors, so
okay.
Tim was involved in that.
Well, I think we can modernize them. I think we can, crispen them up. Okay, but so the issue here is, see, this is a case where it's like getting out a time series versus getting out a table of values, right?
Something like that, yes.
Jose.
Hey.
We are looking at Geo Density Plot, and realizing that geo elevation data gives us something that is very hard to use in density plot. So, I mean, the issue is, what is the analog of time series for geodata? Roger, that would be for you.
Well, this would be field data. So there are two kinds, and so the original goal was to have something called spatial data. We're not working on that now. We're working on spatial point data, but this is not it. This is a field. So there's a value for each point in space for the elevation of Mount Everest.
Okay, I understand that. But so my question is.
So what are the attributes you want from such a data object? You want to be able to search and pick things and look things up and compute with it.
Right, I understand. But I mean, the point about a time series is that it associates raw actual dates with values. Right?
Yeah, and this is the same thing for a field.
I'm aware. A geo field, basically.
Well, right, any field. But then the question is, what are the operations you want on it?
I understand that.
That's what you like time series, because you can operate on it. It's not just dead meat.
Yeah, I understand.
So the issue here is that the result is missing the coordinates, right? It's not
That's
about
correct.
interpolation.
Yes.
So there
Yes.
is a third argument in GeoElevation data that allows you different types of.
What's the second argument?
The second argument is the type of elevation, the elevation with respect to the ellipsoid, with respect to sea level, etc. And the third argument allows, for example, to return a geoposition, which would have a coordinate for each value.
Okay, so I think that's something where we'd say automatic,
And
then
then
we'd say
geoposition.
quotes geoposition.
I think it works both ways, with and without quotes.
Okay. And what does that mean? What does that blue thingy mean?
It's just, it has so many points that it's just drawing all of them. But
that seems like a bug. I mean, that's a minor bug.
Yeah, it's due to very many points, 200,000 points. So now, I'm not sure that that's going to take the geopositions, but that has all the values of the coordinates.
Okay, but so that's a geoposition. I don't understand what the structure of it is, but this should clearly work.
It's an array of triples, lat, long, height.
I see. So if that worked, if Geo Contour Plot and Geo Density Plot took those tripled geopositions, then this would at least deal with this issue, right, Brett?
Correct, which is what I'm not sure why it hasn't returned yet.
Because it has 200,000 points, and because
Yeah,
Contour Plot.
I mean, but no, it still shouldn't be that slow.
Okay, but
because that's what it is using in the first example there in the docs.
Well, maybe I used a slightly different. I mean, you've used geo zoom level of 10 and things like that.
Yeah, so it may have downsampled the points, but
by the way, you don't need that geo bounding box thing. The thing that I used with geo range is a more convenient way to do that. You saw that, right?
Right. Yeah.
Okay, but so now my question would be, as we wait for this. Okay, so fine. So you have successfully used the geoposition triples for this.
Mm-hmm.
Even though I didn't see that in the documentation. What is the input form? I see location value. Okay, so then an alternative to that is location, which is a 3D location.
Scroll down a little bit.
Yeah, I see.
Well, no, it's actually even farther down.
Okay, what on earth is this? All right. I don't understand this at all. What's green? What's yellow?
I mean, so green is going to be some sort of park.
So it doesn't fill between the contours here. It just draws the contours.
Right. So if you did a geographic with that same around Mount Everest with the same range.
Yeah.
Yeah, the colors should match up with that.
I know I have to delete some things here. Okay. It's kind of random. Okay. All right. Okay. All right. Fine. But now what if I wanted to, so if I do a geo density plot on this, then what's it going to do? Is it going to superimpose some kind of color layer on top of the...
according to elevation in that case.
Okay.
Which I don't think is going to be the most interesting or beautiful thing, but...
Okay. Okay, well, that's cool. All right, so fine. So this, I understand what Geo Contour Plot is doing. Now, what if I want to fill in the contours, contour shading?
Yep.
Okay. Does it actually look decent, and do you have decent settings for that?
I don't remember. It's probably still using the default color function.
I suspect that'll be wrong, and especially if it's going to superimpose on the base map.
Right. I mean, so probably we should at least switch it over to what Geo smooth histogram and geo region value plot use sort of a light to darker, lightish yellow to darker brown sort of thing. Is I think what we've come up with as being the best contrast for our typical base maps. Can you bring the Geo Density Plot.nb notebook to the front? I want to see what the dimensions on the Geo Position there are.
Say 11,000 points, very different number.
Yes.
Okay. All right. So the thing we were discussing. Okay, so it sounds like we're not yet ready to iterate. We'll wait for this. We're not yet ready to iterate on the colors for the vector plots here. Because you're going to do some work on that before we want Jeremy involved in that, I think.
Right. Density plot finished, looks like.
Let's see. Okay. So it's going in. It's kind of oranging. It's got an orange tinge on top of the base map.
Correct.
So it could be worse. Okay. Any comments from design folk here? Jeremy, Tim? Oh, okay. All right.
It's hard to have a real opinion without seeing more samples. So that's, I'd like to see lots of cases before really chiming in.
Fine.
Because we went through a lot of cases when we were coming up with that color.
Which
originally.
color? This color
This
here?
orange color, yeah.
Yeah, I think we're going to have rename it. We can have a plot theme which affects both the geographics. Do we have plot themes affecting geographics yet?
The GeoViz functions, yes. Geographics, no.
Okay, because that should be coming soon. Now that we have the new Geo server, thankfully, in place, we should be able to do that. That's my understanding, at least. Jeremy, have you been involved in that yet, of modernizing our geographics colors?
No.
Okay, so I think that's a coming story. Okay, let's see, where did I put the help? Over here. Okay, let's keep going here. We're out of time already.
So the next group,
Complex plots. Complex, wow, what the heck do you do with that? Complex vector plot. So what does that mean? That means complex vectors of complex numbers.
You view
Treating
a complex number
as a vector.
Yeah.
What about vectors of complex numbers?
Do you mean a list version or something?
Those colors are ugly.
Yes.
I'm sorry, those are ugly.
Sure.
So I see. So this is a complex number plotted as a vector, as opposed to a vector plot, which is a vector field plotted with vectors. So this is viewing the complex number as defining a vector in complex.
It is.
Way.
That's what
I know it is.
are.
I know. But there's another meaning that could have, which is a complex vector plot could mean the four-dimensional thing of, a pair of complex numbers in a pair vector.
Right, C2.
Yes.
Yeah, that's usually called complex maps. When you want to see how.
Yeah, fair point. That's true. Yeah, so that's a complex map plot, effectively. Something like when you have a conformal map or something.
Right.
Yeah, we have no capability to deal with that from a visualization point of view right now, right?
Well,
correct.
Well, parametric plot effectively does it, but we don't have an easy, that shows you a pair.
That shows the mapping, really. Yeah.
It's very amusing. I mean, talking of conformal mapping, this is highly relevant. Complex region plot is highly relevant to that.
Of
How do we
course.
make a Joukowsky airfoil?
Yeah, it's down there somewhere.
I think it is down there somewhere.
So, by the way, I wrote this function. It was in 4.2 first time, so you know.
Yeah, if you get down to applications, it should have the airfoil. Didn't it? Where was
No airfoil here.
Maybe it was in the
Okay.
contour plot one.
Well, anyway, it doesn't matter. But okay. So then, wait a minute. What's complex contour plot? The same thing with, I don't understand how that, because there's not a vector. It could be the abs. What defines the contours? The heck is that? Wait a minute. That is a real function, right? That's the abs of this is a real function. But what if the values are complex?
Then there aren't contours.
What do you mean they aren't contours? So it has to be a real valued function.
Typically a point.
Right. If f of z is equal to a constant, then it's either at a point or it's the whole plane.
If it's analytic,
Yes.
I'm sorry. So f of z, in this case, what we're plotting is an f of z, which is a real number.
Yeah.
Then you're plotting the contours in the complex plane of the values of that real number. But what I'm asking is if f of z is a complex function, is maps complex to complex.
Yeah.
Do you have any way to plot it?
Right. But if you have that function, f of z equals to z naught or w or something.
Well, f of z equals z squared, let's say. Something very simple. Just it maps every function, every complex number z to z squared.
Right. But what's the inverse image of, a constant? Let's say 1 plus I, z squared equals to 1 plus I. What's the inverse image of that?
Well, maybe more than one, but I mean, why do we care about the inverse image?
Because it's mostly going to be a point or a few points. Because this is what contours plots, right?
I don't understand it.
Okay. So if you have an analytic function,
yes,
right? There's this theorem in complex analysis that says that if something is true on the real line and it's analytic, then you can extend it to the whole plane.
Yeah. Okay.
Right. And so sine squared plus cosine squared equals 1. You prove on the real line, and then it's true everywhere in the complex plane. A consequence of this is that if a function is constant on the real line, then it's constant in the entire plane. And
right. So this is a story of both analytic continuation and things like Cauchy-Riemann equations. Is that true? Well, whatever. It doesn't matter. Okay, I know that result. So
right. But a consequence of that is that if you have an analytic function equal to a constant, then it's either going to be a point or it's going to be the whole plane. There's sort of no curve case.
Okay. But this function, so your basic claim is if f of z is a complex, returns complex numbers, then there's nothing interesting it can't do anything interesting.
Correct.
Yeah, that's unobvious to me. It's an interesting math claim. I mean, certainly something in your possible issues section here.
Mm-hmm.
What is this? Okay, that's independently plotting the real and imaginary parts as contours.
Right.
I mean, that's very traditional Yankee MD type representation.
Sure.
Mm-hmm.
Now, why is it? I mean, that would be an obvious default to take. If you give a complex function to plot that it is effectively because there is a re-im, we could say re-im of that. Okay, so let me just understand here. So if I were to do the following thing, let me just try this. If I were to say re-im Bessel J 0, Z. Sploff. What went wrong there? Seems wrong to me, because I mean that is going to return a pair, right? I don't see why it shouldn't.
Can you wrap evaluate around that? I'm just curious if it changes anything. I don't think it does, and I think this is a case that Roger and I were discussing. Was it late last week or maybe Monday?
Yeah.
What does contour plot do in the case of two functions like that? If I say contour plot of let's say, I don't know. X
I mean, rem of Bessel J 0 x plus iy, or fine. And it does the same thing.
What is that?
So I'm wondering why you. So
I don't understand that at all. Is it doing something special for that pair?
I'm curious. So do add equals to 0 to both of those.
But it's going to give this the 0 point. I mean, it's going to give this the 0 contour.
Right.
Does that not have a 0?
Or is it only using the last?
Oh,
point
no,
somehow?
that's a point. No, look, that's a
right.
0.
Right.
Okay.
Right, and so contour plot, when you give it a list, it assumes that it's always going to be the equational form.
Okay. How do I get multiple things plotted on one? I guess I just did that with equations here. But if I wanted it not equational, then the superposition doesn't make. You're claiming the superposition doesn't make sense because you just filled the whole plane.
I think we did that. We made that choice back then. But one could say that also that if you're going to have several of them, one could sort of say that contour shading is automatic anyway, so it shouldn't do anything. That's an automatic behavior. If you have multiple sets of multiple contour ISO levels. But then we need to define a style that they all style differently. Kind of what was achieved with show in the other case. But I think that
I understand. But I mean, having different contour colors of contour lines,
which is what it's doing in Out 15 there as well.
Yes, I agree. It just doesn't do it for the multi-contour case.
Right. And so
I think it
needs to certainly simplify those red and blue plots coming out of complex contour plots, and that would then presumably also flow backward into
but
contour plots.
The question that I have is, if you find that the function f of z in the first argument of complex contour plot is real, then that's absolutely fine. Then then there's a trivial contour plot. If it's always real, then the imaginary contour plot is trivial. If what you did was to just say we're going to take the re and im parts of f of z, and we're going to do differently colored contour lines for the re part and the im part, then you would have something there. As opposed to, in other words, I think we need to solve the problem of multiple contour shading, of superimposing two things with contour shading, which I bet we could do. Because if we could do that, then all we have to do for complex contour plot is just do that. Just say if it's complex, then you do the one for the real part, you do the one for the imaginary part, you superimpose them.
I mean, we did solve it in complex plot.
Okay, how is it solved there? So you're saying if I say complex plot,
if you have to pick the right color function that shows both.
But let's say I do this. Say area AI of z, and I say z goes from minus.
Oh, I take that back. No.
I don't think it does anything.
No, not for multiple functions. Sorry. No, it doesn't.
I shouldn't complain about data sets, but
okay, so that's a different, separate issue. Why is this so slow? Okay, that's cool. Okay, but so you're saying it doesn't superimpose. It's a one function deal.
Right. I mean,
One
it
function deal,
saturates that area.
but it will, depending on which color function you pick, it will make the magnitude. And this one only shows the face right now.
It's a little bit of magnitude. You see it in the
Yeah, I
left
see it a
corner.
little bit. Yeah,
I just think this color map is really, really bad.
sure.
I don't like it anymore. I don't know whether Jeremy or Tim has a comment on this. And personally, I'm beginning to get tired of our pure blue. I think we should liven up the default.
Well,
What?
that's exactly what we predicted when we did plot themes. It's like this is going to need a revamp every now and then
Yeah, I know.
because it's just
Every few years, right? World changes. By the way, on our live stream, there are some questions here that Carl is asking. Be great to see better GeoTIFF support. Anybody want to comment on that? Jose, are you aware of what's happening with GeoTIFF?
We are working on updating the GDAL library, which handles the reading of formats. So we expect these to be better.
Okay. In 12.1?
I'm not sure 12.1, but if not, then the next version for sure.
Okay. Sandra is suggesting we might need a black and white base map. In the case, yeah, I agree that would look a lot better if we're going to have coloring on top of the base map. That having a black and white base map would make more sense. I mean, it's going to look totally weird with, the orange is not going to mix well with random, freeways, which happen to be in orange as well. It's
I've seen dark mode like base maps that look really good too with color.
well,
I
that's
mean, we do a little bit of that with plot theme goes to marketing in the GeoVis plots. Yeah, so
wait a minute. That is horrendous. Sandra is pointing out, what a horrendous fact. Do you see that? He's pointing out that orange and blue are switched around in these orders.
this is on purpose.
I know.
What do you mean it's on purpose? Okay, explain. I mean, it looks nice with the orange one, and the bottom thing looks nice with orange.
I mean, so one of the considerations in that is that, so if you are, say, combining plot with histogram or, a list plot with a bar chart or something,
Yes.
that the curves and the region.
Well, that's reasonable. I mean,
are
arguably,
contrasty.
couldn't have actually used the same colors as a flip around. It would have been better to
shift the color sequence or something.
Yes. Sandra is complaining that it really becomes confusing. But I think we should look at that. That's a really good point. I think we should consider just using slightly different color palette here to avoid this flip around thing.
If you mean just a darker version of yellow and blue for the curves, I believe we had that at one point, and Savalsh complained that there wasn't enough contrast when he can put a PDF curve on top of a histogram.
Okay. I claim this should be looked at again. I claim this is goofy. I mean, in other words, we would be better off not ever having a blue in here. If we went from orange to some completely different color here and never went through blue, we'd be better off.
That'd be very Halloween-y.
Well, it depends what the color is. I mean, I like the blue with the orange. It goes very nicely, but I this point is crazy.
Well, I mean, so on the other hand, the thing is that there's also some consideration of what do we like for what percentage of the time, right? So 80% of 3D plots are one surface.
No, I understand. We like what it is for one surface. There's no problem with one surface, okay?
Right, but I'm saying that each additional surface is a lower percentage of the cases.
I understand that. This is crazy. Okay, we should just pick, color space is big. We don't have to have colors that agree but flip around. See what I'm saying? I mean, it just doesn't make any sense. I'm sure if we go to 4x, okay, if we go here to 4, okay, that's just weird, right? It's just weird to have those first two flipped around. Surely we can do something about that. I don't know what the right thing to do is, but we can do something about it. Okay, listen, logistically, I am really supposed to go to another meeting here, but I know we're going to come back to this one. We need to finish off this one, and then we've got other ones to do. So I suggest what we do after this, when I come back from this next meeting, is we do, because I know we've got to finish a bunch of these design reviews today. So Roger, we should just have a rolling design review thing where we bring in the different people who are involved in the different design reviews that we're trying to do. Okay. So we can live stream it. Is anybody paying attention here? Can we figure this out, please? Do I have to go do the logistics for this?
No, we'll take care of it.
Thank you. Okay, so I'll be back here with everybody soon, and I encourage people on the live stream. We should be back. So I think we should continue this one to just see whether we can just finish this one, and then we'll go into graphs and networks and so on. Okay, and I'm going to completely skip that outside meeting. Okay, all right. Thank you all very much. See you soon.
See ya.
Bye.